In the summer of 1950, strolling to lunch at Los Alamos National Laboratory in New Mexico, physicists Enrico Fermi, Edward Teller, and Emil Konopinski discussed the probability of intelligent life in the universe, birthing Fermi's famous statement, "But where is everyone?" Let's explore. Hi everyone, and welcome to Project Bluebook, where we explore all things unidentified. I am Thor, and thanks for tuning in. It's important to know this theory as context to any discussion of unexplained phenomena because of how it is used as logic to reject evidence that doesn't fit. Fermi's logic was based on assumptions that have not remained static since 1950 when it was introduced. Assumptions that are not facts, and many have since been rejected, even blown out of the water, like by recent disclosures of the Pentagon. But first, let's examine the Fermi Paradox theory, and forgive me if this goes too deep into the details. It's just necessary to be thorough. The nuclear physicist, Nobel Prize winner and godfather of the nuclear reactor, Enrico Fermi, during the infamous stroll with the inventor of the hydrogen bomb, after jokingly discussing disappearing trash cans in New York City and UFO sightings, suggesting mockingly there might be a connection, Fermi posed the question of probability for the discovery of matter traveling faster than light as a parallel to interstellar travel of intelligent beings. When his buddies suggested 1 in a million chance of the discovery of matter that traveled at light speed within decades, he suggested a vastly higher number as more likely to be true. And during lunch, when everyone had moved on to other conversations, out of nowhere, Fermi asked, "But where is everyone?" The logic problem here is easily understood when you completely dismiss all UFO sightings footage, as well as other evidence, testimony and eyewitness accounts. Plus, you accept 1950s theory regarding the age of the universe being 13.8 billion years, even if it has, according to physicist theories of late, fluctuated by 2 billion years since then. And most importantly, when you understand the distances between solar systems, measured in any number of light years, single or double digit, between galaxies measured in thousands of light years, compared to the size of the universe, which is measured in millions of light years across. And you also accept as fact that we cannot travel faster by limitations of laws of physics than the speed of light, which is about 9 trillion miles in a calendar year equals 1 light year, and you quickly realize the distances are insurmountable. Remember, the James Webb Telescope is now reading light emitted more than half the distance in time to the dawn of the universe, according to the Big Bang theory. Yet some physicists have suggested there was no Big Bang at all, that the universe has no beginning, and one of them went by the name of Stephen Hawking. Fermi's problem first involves mathematics, numbers. There are estimated to be over 2 to 400 billion stars, like our Sun, in the Milky Way galaxy alone. And with millions of galaxies in the universe, the number of stars grows to 70 sextillion, that is 7 with 23 zeros behind it. That's the number of stars. So Fermi's stand on the probability of intelligent life and advanced civilizations in the universe, applied similarly as with matter traveling at the speed of light, according to him, there should be greater than 1 in a million of such stars, giving birth to intelligent civilizations, which by calculation produces a number of intelligent civilizations in the universe at around a billion civilizations. The second part of the equation has to do with civilization's ability to overcome all obstacles in its way as it evolves to govern its destiny against all external forces. According to his theory, and Fermi provided calculations, it would take between 5 and 50 million years for an advanced civilization to expand beyond its own galaxy. There's been a lot of great brains on this since Fermi's passing in 1954. Soviet astronomer Nikolai Kardashev in 1964 introduced a scale whereby a Type 1 civilization was technologically limited and stuck to its own home planet. That will be us. even as we're just beginning to break out. A Type 2 civilization is able to expand to the reaches of its own solar system. A Type 3 intelligent civilization would colonize its entire galaxy. In 50 million years, according to Fermi's most conservative estimate, we, Earthlings, Homo sapiens sapiens, are merely 60 years old if we measure by our first physical excursion off-planet. Astrophysicist, astronomer, and the godfather of the SETI program, Dr. Frank Drake, in 1961, in order to stimulate a dialogue in the scientific community about extraterrestrial civilizations, came up with a Drake equation, which goes something like: one star is formed on average once a year in any galaxy. A conservative estimate with 1/5 of such stars also forming a planet or planets, with 1/5 of those having between 1 and 5 planets, with perhaps another 1 in 5 of those having an orbiting planet that is capable of developing life because it is located in a Goldilocks zone, not too warm, not too cold, and in a stable heliocentric orbit. And perhaps 1 in a million of those capable of surviving the bombardment of nature to develop intelligent life at all. This means the number of civilizations equals the calculation of the formation of stars times the fraction of stars forming planets times fractions of stars with multiple planets times fraction of stars with planets located in a Goldilocks zone. And since these are all fractions, the number keeps diminishing. If we then assume 1 in a million developing intelligent life, well, guess what? This fractional number would leave between 1,000 and 1 million intelligent civilizations in the Milky Way galaxy alone, and that means a conservative billion civilizations in the observable universe, a number arrived at by way of a second method of mathematics. We are perhaps a million years early ourselves in asking these questions, because there is hardly any empirical, that is, observable evidence, but for proving part of the Drake equation. We are down to discovering stars with planets, and we are now down to observing habitable planets in a Goldilocks zone, while closer to home we're also observing ice and ice water on the Moon, Mars, as well as Jupiter's Io and Europa. So what's stopping them, asks Fermi. Distance? If we can't travel faster than the speed of light, it would take a generation or two to travel one way just between our neighboring solar systems, even at the maximum speed of light. Self-destruction? Before we reach our ability to travel interstellar, we destroy ourselves by way of nuclear war, environmental or other causes. Natural destruction? It could occur, like the asteroid that killed the dinosaurs on Earth 60 million years ago. What about interstellar wars? Let's say a civilization does find another. Perhaps the first instinct is to destroy it before being destroyed. Or a civilization is born, it lives and dies in a span of time that does not suffice for interstellar travel. We have no comparative data on how long advanced civilizations can and do exist. Or perhaps they deliberately hide away from us. And that's an interesting theory and worth contemplating. As far as communication goes, barriers, bandwidth, frequencies, dimensions, speed and distance, as well as their level of intelligence possibly being so vastly different, it would be like trying to teach ants the purpose of traffic signs. All potentially play a part in complicating communications at any distance. A paradox, according to the dictionary, is a seemingly absurd or contradictory proposition which, when investigated, may prove to be true regardless. End quote. The problem with the Fermi Paradox as a hypothesis is precisely the birthing of a reaction like, "But where is everyone?" as a proof for the hypothesis. Extraterrestrials don't exist, case closed. We still don't know the exact age of the universe. We don't even know if it was born. We don't know the time it takes to develop intelligent civilizations, a mere 25,000 years. And most importantly, we don't know physics well enough to positively conclude that traveling faster than the speed of light is impossible, nor can we proof test Einstein's theory of relativity, that with sufficient application of energy, gravity, and therefore time, can be warped onto itself rendering concepts of distance meaningless. We don't know if wormholes exist, even as more and more physicists suggest they do. In other words, we don't have enough data. Latest observations of the universe have given rise to theories about Dyson spheres, suggesting the existence of megastructures engulfing entire planets, possibly for energy harvesting. Fast radio bursts continue to emit patterns we cannot explain. Pulsars exhibit unexplained behaviors as well. In other words, there's a whole lot we don't know or understand. A universe limitless in size and a universe with size limitations are equally incomprehensible to us. Just as a universe where we are the only civilization and a universe teeming with civilizations are equally terrifying. Meanwhile, we continue to gather evidence of alien existence on Earth, that they may have been here since before our time, that they intentionally shield their intentions from us while enabling peekaboo view of their realities, the real world we live in, conditioning us and influencing our evolution. We have physical evidence, comparative data points, thousands of eyewitness accounts, and whistleblower testimonies suggesting human-alien collabs. And we have photos, videos, and artifacts, as well as biological and chemical trace evidence, along with their radiomagnetic energy signatures. Fermi asked, why have there been no alien observations? And why have there been no alien artifacts found here on Earth or in our solar system? Because if they existed, and they should, based on his own theory of probability, well then we should have seen them and discovered their stuff. And according to Fermi in 1950, we had not. That is the Fermi Paradox. Where is everyone? You see, in terms of human evolution of thought and technology, as well as evidence of alien existence, 1950 was a really long time ago. The real paradox of the Fermi Paradox, to me, is that they were strolling to lunch in the middle of the day at Los Alamos National Laboratories, New Mexico, in the summer of 1950, 3 years after Roswell, which took place only 200 miles to the south, and 10 years after the discovery of the Dulce complex, located only 100 miles to the north. Right there in the middle, between those two hotspots of alien and UFO activity on Earth. That is perhaps the real paradox. You can watch and listen to this and other podcasts on Project Bluebook, where we explore all things unidentified. Each day, let's practice compassion and kindness. And please subscribe. I am Thor, and thanks for listening. See you next time.